So now we've looked at the unit circle and special right triangles. Now we're going to apply this to be the trigonometric functions of any angle. So if theta is an angle in standard position with point PXY on its terminal side, and the radius is not 0, so this is going to be R. We're going to use SOHCAHTOA to figure out our trigonometric functions. So the sine of theta is the opposite, or y, over the hypotenuse, which is r. Cosine is x over r, and tangent of theta is y over x. Now, my cosecant is just the inverse of my sine, so it is going to be r over y. Secant is r over x, and cotangent is x over y. So we're going to use these in example 1 to find the values of all 6 trig functions of an angle in standard position if our coordinates are 3, 4. So that means that this side is 3 and 4, and that's theta. So now sine of theta is going to be y over r, or 4 over, from the Pythagorean theorem, 3 squared plus 4 squared, and then the square root of that is the square root of 25, or 5 for my hypotenuse. The cosine of theta equals x over r, or 3 over 5. The tangent of theta equals y over x. Cosecant of theta equals 5 over 4. Secant of theta equals 5 over 3, and the cotangent equals 3 over 4. In our next example, we're going to use a triangle with our coordinates at -5 and 12. And so here, now here's my triangle, and in this case, this is going to be theta here. So this side is 5, but it's negative, and this side is 12, and I'm going to use the Pythagorean theorem to find my hypotenuse. And so this is 25 plus 144 equals c squared, so c equals the square root of 169, which is 13. So let's look at all 6 of our trig functions. So sine of theta is y over r, so that is 12 over 13. Cosine of theta equals -5 for my adjacent side over 13. And my tangent of theta equals 12 over -5. To get my cosecant, I invert my fraction from my sine, so I get 13 over 12. Secant of theta equals -13 over 5, and my cotangent equals -5 over 12. We can determine the sign of our trigonometric functions in each of the 4 quadrants just from the definitions of the functions. So for the sine, that is related to our y value. So we're going to talk about in quadrant 1, our sine of theta. Our y value is positive, so is our sine. In quadrant 2, our sine of theta is still positive. I'm still above the x-axis. But in quadrants 3 and 4, my sine of theta is going to be negative. The cosine is related to the x value. And so now in quadrants 1 and quadrants 4, I have a positive cosine. But in quadrants 2 and quadrants 3, I have a negative cosine because my x value is negative. The tangent is related to both my y and my x, and they're divided. And so if they are both positive, like in quadrant 1, then my tangent is positive. Or if they are both negative, like in tangent or in quadrant 3, then my tangent is also positive there. But if I have one positive and one negative value, then my tangent of theta remains negative, like in quadrants 2 and 4. So in example 3, we're given that the tangent of theta equals negative 5/4. So we're looking at either quadrant 2 or 4. But then we also know that the cosine of theta is greater than 0, which occurs in quadrant 1 or quadrant 4. So the one that matches for both of those is quadrant 4. So when I draw this, I know that because tangent is y over x, my y value is going to be in the negative direction, and that's going to be negative 5. And then my x is going to be a positive 4, so that is where my angle goes. And then this is my triangle right here. So that is 4, and that's negative 5. And then we are going to have to solve for this hypotenuse using our two sides here. So we know that c squared equals 4 squared plus negative 5 quantity squared. So that is 16 plus 25. So c equals the square root of 41, which isn't a nice round number, so we'll leave it like that. So our sine of theta equals y over r. So that is negative 5 over the square root of 41. And our secant of theta equals r over x. So that equals the square root of 41 over 4. In example 4, we're going to find cosine of theta if sine of theta is negative 3/10. So because that's negative, I know it is either quadrant 3 or quadrant 4. And then if the tangent of theta is greater than 0, so I know that that is either quadrant 1 or quadrant 3, which means that I must be working in quadrant 3. So now we're going to pick apart the statement that if sine theta equals negative 3 over 10, then we know that has to equal y over r. And so because I'm working in quadrant 3, y has to be the negative value, so y equals negative 3 and r equals 10. Next, we want to find x because we need that for cosine. So now I know that x squared plus y squared equals r squared from the Pythagorean theorem. So x squared is my unknown, y is negative 3, and then r is 10. So x squared equals 100 minus 9, so that equals 91. So x equals the square root of 91. And now we're going to use that for cosine of theta equals x over r, so that equals the square root of 91 over 10. If theta is an angle in standard position, then its reference angle is the acute angle theta r formed by the terminal side of theta and the x-axis. And then you draw a vertical line from a point on the terminal side to the x-axis, forming a right triangle, and this line will be opposite your reference angle in the triangle that's formed. It's a lot of words, so let's look at an example. So if we are looking at theta equals 300 degrees, so that's going to be, I'm going to go around past 270 and stop here. So then I'm going to draw like that, and this one here forming an acute angle, so less than 90 degrees with the x-axis is my reference angle. We can then calculate it because that is 360 if I had gone all the way around, minus 300 equals 60 degrees. In our next example, theta equals negative 135 degrees, so that is going to be around this way and stop halfway around. And so my reference angle is going to start at the origin and go like this, and then that is my reference angle. And so I could have gone around 180 degrees, but I stopped at 135, so my reference angle is 45 degrees below that x-axis. In our third example, theta is negative 3 pi over 4. So if I start here, and I go 3 pi over 4, so 3/4 of pi, not quite all the way around. This is actually exactly the same spot as an example B, but now we're working in radians. So now I am taking pi minus 3 pi over 4, so my reference angle is a single pi over 4. You'll notice that all of these are positive numbers.